Hello children, Namaste everyone, welcome back to the mathematics class. Dear children, in our last videos we have seen chapter from arithmetic progression, then from algebra, quadratic equation, and from geometry we have studied about circles. In circles we have studied what do you mean by a circle and different parts of the circle, and also tangents and secants. So let us recall what we have studied. See, what we mean by tangent we have seen, and some properties of tangents we have studied. See, what are the properties of the tangents we have studied? One property is a tangent touches the circle at one and only one point. See, on the circle it touches one and only one point. Tangent touches at one and only one point. And if you join that point of contact to the center, it becomes a radius. Radius at the point of contact with the tangent forms 90 degree. That is one of the important properties of the tangent what we have studied, isn't it? Then another property, you can draw maximum 2 tangents to a circle from an external point, from outside, from an external point. One theorem also you have studied, 2 important theorems you have studied. One theorem says you can draw from an external point. If it is the external point, you can draw 2 tangents, maximum 2 tangents. So you must know this. Now let us see how many tangents can be drawn to a circle. How many tangents you can draw to a circle? You can draw to a circle, you can draw many tangents. For example, this is a point. If you can draw a tangent like this. So this is a tangent. See, at this point, this is a tangent. If you go for very near, a very next point of this point, the tangent only different. See, this is the tangent. To this point, it is a tangent. So how many tangents you can draw? On the circle, you can draw many tangents. Wherever it may be, you can draw many number of tangents. Infinite number of tangents you can draw. So you must remember this. And another important thing is, see, tangents at the ends of the diameter are always parallel. See, this is the diameter. At the ends of the diameter, if you draw the tangents, these tangents are always parallel to each other. These are parallel to each other. Why? If it is 90 degree, here also 90 degree, because it's a property. And here these ends of the tangents, if you draw the tangents at the ends of the diameter, that 2 tangents are always parallel to each other. So with this, we have to solve some problems. Few problems we will solve today, and the remaining problems you can understand. I will send the notes, you can understand that problems. Okay. First, let us see from a point Q. See, look at this here. From a point Q, the length of the tangent to a circle is 24 centimeter, and distance of Q from the center is 25. What is the length of the radius? See, what is given from a point Q. From a point Q, look at this, according to this question, from a point Q, length of the tangent to the circle is 24. Length of the tangent is 24. This is 24. This is the tangent. See, this is the point Q. From a point Q, see, this is the point Q. Length of the tangent is 24. This is the tangent. Let us consider this is 24. Okay. Distance of Q from the center. See, this is the center. Distance of the Q from the center. See, this is 25 centimeter. This is 25 centimeter. So, what is the length of the radius? See, what is the length of the radius? So, this is how much it is asked. Let us name this one as O and say P. Let us name it as P. Now, it is asked length of the tangent from the point Q is 24, and from the center to that point is 25. Distance is 25, and it is asked what is the radius of the circle. So this is the radius. See, you know, using the properties of the tangent, we have to solve this question. How to solve this question? You have studied one property. What property you have studied? The radius with the tangent forms 90 degree at the point of contact. That is a property, one of the properties of the tangent what you have studied. So it is 90 degree. Therefore, triangle PQO is a right angled triangle. Why? Because here it is 190 degree. And if it is 90 degree, you know this is the hypotenuse. In a right angled triangle, according to Pythagoras theorem, what you have studied? In 9th standard you have studied about Pythagoras theorem. Once again you are going to learn this class also. In a right angle triangle, if the triangle is in a right angle triangle, say in a right angle triangle, if it is 90 degree, this is the hypotenuse. Side opposite to the right angle is hypotenuse. Square on the hypotenuse, according to Pythagoras theorem, square on the hypotenuse is always equal to sum of the squares of the other two sides. Sum of the squares of the other two sides. So if you apply that one to here, this is 90 degree, this is hypotenuse. Square and hypotenuse. See here, I will take it as OQ. OQ square is equal to OQ square is equal to OP square plus PQ square. PQ square. Apply the value. OQ square, you know, 24 square is equal to OP square plus PQ square. So OP square plus PQ square. So PQ, you know the length PQ, it is 25. PQ is equal to 25. Therefore, OP square is equal to, bring this 25 this side, it becomes OP square. See, OP square plus PQ square, this is 24, sorry, it is 24, OP is 25. So, OP square is equal to 25 square minus, if you bring 24 this side, 24 square, or let us write like this, OP square is equal to 25 square minus 24 square. See, 25 square minus 24 square. So, what is 25 square? It is 625. 24 square, it is 24 square. 24 into 24. See, 4 4s are 16, 1, 4 2s are 8 plus 1, 9. 2 4s are 8, 2 2s are 4. See, what is the answer? 576. 576. So, 625 minus 576. How much? What is the answer? 9 and 4. 11 minus 4 is equal to 11 is equal to 4. So 49. OP square is equal to 49. Therefore, OP is equal to root 49. Root 49 is equal to plus or minus 7. Here minus 7 is not possible. It must be plus 7. So length of OP is equal to 7 centimeter, or length of the radius is equal to 7 centimeter. This is how we can solve the question. Okay. Next. So this type of question using the Pythagoras theorem, you can solve the if any length is not given, unknown, you can find. Suppose the radius of the circle is given and tangent is given, find the distance between the center and that point. You can do. Or this is given and this is given, this is not given. Then if the external point of the center length is given and radius of the circle is given, find the length of the tangent. Then also you can, using the same theorem or using the same principle, you can solve that question, isn't it? Next, one more question. Look at this. See, sometimes the angle is given. See, you know properties of the triangle, you know the angle. See, here there is a question like this. See, this is one external point, say P, I will name it as P, and these are two tangents, say PQ and PR are two tangents, O is the center of the circle. See, R and Q are the point of contact. Now it is given you to here the angle is 110 degree. For example, it is 110 degree. What is the angle at P? What is the angle of QPR? What is the angle at P? So you can calculate easily. How you can calculate? You know. Now look at this. How to calculate the angle P there? It is given here. P is external point. PR and PQ are two tangents. Touches the circle at Q and R. this angle? You know, now look at this. See, the figure is like this. What type of figure is this? See, what type of figure is this? This is a quadrilateral. You know, it is 110 degree here. And what is this angle? It is given, isn't it? If you know three angles, you can find this angle, because you know the sum of all four angles in a quadrilateral is how much? It is 360 degree. But here you know what is the angle here according to the properties of the triangle. It is 90 degree, and here it is also 90 degree. So 90, 90, and here 110. What must be the angle? So 90, 90, 180, and 110 is here. So the sum of this angle and this angle is always 180, because sum of this angle is 180. Other 180 angles here and here. Okay. So remember always the sum of this angle and sum of this angle is 180. If it is 110, what should be the angle here? So 180 minus 110. What should be the angle? It is 70 degree, isn't it? So angle is 70 degree. Remember always, if it is 100, what must be the angle? So sum of this angle and this angle is 180. If it is 100 degree, what must be the angle here? It is 80. If it is 80 degree here, what must be the angle here? It is 100 degree. So remember, always in any tangents like this, the sum of this angle and this angle is always 180, because sum of this angle and this angle is 180, 90 plus 90. So on this basis, we have to solve many questions, and some other construction also is there. So that construction we will learn in a separate chapter about construction. Okay. So this is about to find the length of the tangent, radius or distance between the center and the external point, and also to find the angles here between the tangent or the center angles. Like this we will do. Okay. So try to understand this question. Let us learn one more question. Look at this. Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. It is very important question in the examination point of view. So remember, it is there in your textbook. Two concentric circles. What are concentric circles? Circles having same center but different radii. You have studied. Two concentric circles. Let us consider these are two concentric circles. Okay. Two concentric circles. What is that? Two concentric circles are of radii 5 cm and 3 cm. So one is of 5 cm, another 3 cm. See, I will take this as the radius of this circle. It is 3, and radius of another circle as 5. So this is 5 cm. Radius of the bigger circle 5 cm, and radius of smaller circle is 3 cm. Find the length of the chord of the larger circle. Chord means what? The straight line segment which touches the circle at two different points. Find the length of the chord of the larger circle which touches the smaller circle. This chord must touch the smaller circle like this. See, it touches the smaller circle. You have to find the length of the chord. What is this length? It is asked you to calculate. Okay. So what is the length of this chord? See here, what happens is, it is given. Look at this. You know, if it is a tangent, this is the radius of the smaller circle. It forms 90 degree. It becomes the right angled triangle, isn't it? I will name it as, say, for example, A, B, C. A, B, C is the chord, and O is the center of the circle. Let us consider O is the center of the circle. Center of both the circle, concentric circles. Now, what is the length? Can you find out this length? What we have studied now? Can you find the length of AB? If you know AB and BC are equal, therefore AC is twice the AB. But you can find the length of the AB using the properties of the tangent. You know this is it is a right angle triangle. OABO is a right angle triangle where right angle at B. Now, according to Pythagoras theorem, we can write the hypotenuse square of the hypotenuse AO square is equal to AB square plus OB square. AO square, it is given 5 square is equal to AB 3 square plus OB square. See, like this. Correct? It is 5 square plus OB. AB square is equal to AB square. OB square is 3 centimeter. OB is 3 centimeter. AB square plus 3 square. OB is 3 square. Therefore, AB square is equal to 5 square. Bring this 3 square this side. It becomes minus 3 square. 5 square is 25. 3 square is 9 is equal to AB square. What is 25 minus 9? It is 16. AB square is equal to 16. Therefore, AB is equal to root 16. Root 16 is equal to plus or minus 4. But here minus 4 is not possible. It must be a plus number. So, for positive number, therefore AB is equal to 4 centimeter. What is the length of AB? It is 4 centimeter. So, now AC is equal to 2 times of AB. 2AB. AB you found. Therefore, AB is equal to 4. 2 times of 4 is equal to 8. So, length of the chord of the larger circle which touches the smaller circle is 8 centimeter. This is how we can find the question. We can solve the question. Okay. So, this type of question may arise in the examination. Next, we will learn another question. Children, look here. A quadrilateral ABCD is drawn to circumscribe a circle. ABCD is drawn. See, look at this figure. The same figure I will draw here. A quadrilateral ABCD. See, ABCD. Quadrilateral ABCD is drawn. Look at this. ABCD is drawn. A, B, C, D is drawn to circumscribe a circle which touches the circle at 4 points. See, circumscribe the circle. Touches the circle at P, Q, R and S. P, Q, R and S. See, this is a figure that is given. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that. What you have to prove? AB plus CD. Look at this. AB. Right here. AB plus CD. What is AB plus CD? AB plus CD. See, opposite sides of the quadrilateral. AB plus CD is equal to AB plus CD is equal to AD plus BC. AD plus BC. See, like this you have to prove. This is to be proved. How to prove this? See, understand the question. A quadrilateral ABCD circumscribe the circle at 4 different points. It touches the 4 different points at P, Q, R and S. You have to prove AB plus CD is equal to AD plus BC. How to do this? Using the same property or properties of the tangents, you can prove this question. Look at this. Now let us come here. A, this is external point. See, it becomes a tangent. The sides of the quadrilateral becomes the tangents to the circle, isn't it? See, look at this. See, this is one tangent. This is another tangent. So from this external point, from here to here and here, these are same, because you know, you have studied one theorem. If two tangents drawn to a circle from an external point, they are equal in length. Therefore, what you can see? AP is equal to AS. Am I right? AP is equal to AS. Correct? So let us consider this as 1 because properties of the tangent. Then can you say, if it is external point, can you say BP is equal to BQ? BP is equal to BQ. Is it correct? Why? Because B is the external point, P and Q are the tangents. BP and BQ are the tangents. So you can write like this. In the same way, look at this point. D is external point. DS and D are same. See, DR is equal to DS. Correct? DR is equal to DS. Why? D is